Hi there, and welcome to the very first episode of Intelligent Anesthesia. I'm Dr. Larry Chu, your host and a professor of anesthesiology and perioperative and pain medicine at Stanford University. Today, we embark on a journey into the heart of where technology meets anesthesiology, illuminating the paths through which innovation can transform patient care. This series, Intelligent Anesthesia, is made for those who are at the forefront of medicine and anesthesiology, from seasoned practitioners to medical students eager to learn about and embrace the future of healthcare. This podcast will navigate through the complexities of the future of technology and medicine, including machine learning, and we'll also dive into principles of innovation like design thinking in healthcare and uncover the roles of interdisciplinary collaboration in improving patient and doctor experiences. So, expect to be challenged, inspired, and informed. Our episodes will bring you into conversations with leading experts, like our guest today, who are pioneering integration of technology into medicine and anesthesiology. Each episode aims to equip you with knowledge and perspectives to enhance patient care and prepare you and your practice for the future. We have an exciting lineup of topics for the podcast, including a deep dive into machine learning, the ethical implications in healthcare, and strategies for integrating innovative technologies into clinical practice. So stay tuned for episodes that promise to expand your understanding and spark curiosity for technologies and how they could impact your clinical practice. So for our first episode, I am thrilled to introduce two guests to you. We're going to start with Dr. Alex Goodell, who is our AIM Lab Fellow and a pioneering anesthesiologist and internist who is working at the forefront of integrating technology into healthcare. Alex's work in the Stanford AIM Lab is helping to redefine boundaries between technology and how we can improve patient care. He's going to join us now. Alex, your projects have a wide range of impacts, from improving real-time data access for anesthesiologists working in the OR to evaluating large language models in the clinical setting. Alex, for our listeners who might be new to this term, could you explain what a large language model, or LLM, is, and how it could potentially, or perhaps is, revolutionizing fields like medicine and beyond, specifically in healthcare and medical education?
So large language models are essentially a new piece of software that is a sophisticated algorithm that has learned a lot about how human language works through analysis of vast amounts of text data. From that analysis, it's able to replicate human language, and because of all of the requirements needed to speak correctly, it has ended up learning a lot about the world that we live in, including, surprisingly, a lot about medicine. And we've seen over the last couple of years an expansion in the abilities of large language models, most notably ChatGPT from OpenAI. And what we've seen is that even trained on general internet data, they're still able to answer questions that physicians, as well as they're still able to answer questions as well as a physician might, and have a fair amount of innate understanding of medicine. What this means is that there are many applications. There's still a lot of things that need to be ironed out and need to be thoroughly tested, but possibilities include using large language model powered chatbots to help patients understand upcoming surgery, to help doctors understand the diseases of their patients, or allow patients to have kind of a personalized approach to the documentation that they receive in medicine. It can be a kind of universal translator for all types of miscommunications. That being said, this is a brand new technology, and there's a lot of evaluation that needs to happen. We have already seen some pretty significant limitations, and it's a brand new field that has a promise to revolutionize medicine and how it's practiced today, and is an area ripe for further exploration.
So building on that, could you maybe share how you're applying LLMs in your projects to improve our understanding of how they could be used in medical care?
Yeah. So one of the things that I'm interested in is evaluating the different ways that large language models can fail in clinical settings. And one of the ways that we noticed early on was that it struggled with calculations. And this is a well-documented fact. And so we conducted a pretty thorough analysis looking at types of clinical calculations that might be done, and finding that it did struggle with a lot of basic clinical calculations. There were some alternative strategies that could be implemented by introducing a calculator tool that would be able to assist the large language model, and this improved performance significantly. Another area I'm interested in is how can we use large language models to customize the experience of a patient, or the documentation that a patient receives, to further their understanding of their disease. So one thing we recently worked on was we took the standard anesthesia preoperative instructions and fed them into ChatGPT, asking it to make the sophistication of the language to meet the educational level of a sixth grader. And we found that it was consistently able to do this. And I think that opens up a wide range of possibilities, and that because these models have a very deep understanding of the intricacies of language, we can modify texts in ways that suit the needs of many different actors, many different stakeholders, like patients, doctors. So you could think of a world where patient notes had a version for physicians, a version for nurses, a version for patients. Really, I think fundamentally changing the way I think about the role of the medical record and the role of patient instructions.
That sounds very patient-centered. I wonder what, besides calculations, besides personalization of information, what other unique advantages do you think LLMs offer or could potentially offer in terms of diagnosing or treating patients that perhaps our traditional methods currently might not?
So I think that one thing that LLMs have consistently shown success in is the diagnosis of rare diseases. Especially, I think the most moving case reports that I've seen are patients that have seen tens of specialists, have no answers, and then describe their symptoms to ChatGPT and are able to get a list of things that other people hadn't thought of. And obviously, that's not medical advice, that shouldn't be acted on. But in some cases, that list contained the accurate diagnosis and led the medical team to the right diagnosis. So I think that there's millions of diseases, and not every physician is going to have seen or learned about every disease. And with the time constraints, with patients with extremely rare or undiagnosed diseases or novel diseases, large language models, because their vast collection of data, seem to be a very helpful solution. I think that's the most poignant example of something that large language models do that humans don't do particularly well.
Very interesting. We're going to get back to you in a second, Alex, but first I want to have the pleasure of speaking with our next guest, Dara Rouholiman, who I really have enjoyed seeing over the years develop in the field of machine learning and the application to healthcare. Dara, you started in the AIM lab many, many years ago when we were working on Medicine X together, and now you have returned, having worked in the field, in the real world, delivering your solutions and innovative engineering work to many startups. And you're working with us now on some solutions in academic anesthesiology. So I'd love you to share with us some of the insights that you gained outside of academia and also share with us some of the work that you are doing now at Stanford and talk about your journey, essentially, over the past few years. So let's start off by maybe having you share an insight that you learned from being in the real world. I would love for you to share one of the key insights that you learned about implementing machine learning in healthcare, in the real world, in industry, outside of academia.
Sure, yeah. Well, it's a pleasure to be here, obviously. But if we're talking about machine learning at industry versus machine learning at academia, well, it's easier to explain the differences of like how large language models basically got evolved in industry and then what that difference is in academia. And that is, I think, at industry where we got to is that large language model or AI, we went toward general AI models, whereas a few years back, industry and academia both were focused more on domain-specific AI models. But now, for the past 2 years, everyone is moving toward building or getting closer to general AI and general large language models or foundational large language models that then can be applied for different fields and domains. And in academia, we are still more focused on building domain-specific AI or large language models. So that's kind of the big difference of where industry is focused on and where a lot of talent and venture capital is at versus academia too. And I think for us here at Stanford is like, we actually love to do both at the same time. And we want to experiment build on top of that general AI approach and general foundational large language models that understands the world in general very well. But at the same time, when it gets to focus on domains specifically, like anesthesia in medicine, or I don't know, legal reasoning and law and legal logic and understanding, then we would love to actually focus more on building domain-specific models. So that's kind of like the biggest difference of industry and academia. And at Stanford, we're in kind of a unique place that we would love, like we actually try to do both at the same time for our experiments. And here at AIM Lab, for our anesthesia ML research projects, we're doing evaluation of those foundational general models to understand what the breadth or general capabilities and understanding of anesthesia knowledge of those models are. And it turns out that like at least it's well beyond my expectations too. But then at the same time, when we have specific tasks, now how do we fine tune either those or go and build a new model that is very much just all about that anesthesia specific task or knowledge? And the insight, I guess, from the industry is that you don't need to dive deep into one specific branch or like a deep understanding of one specific domain in order to have a working model. You can actually just have a shallow understanding maybe for a lot of tasks. And that approach also works. And the industry with the ChatGPT is a very great example that actually shows that a shallow understanding that can actually be applied for a lot of tasks for large language models and can solve a lot of problems. And maybe domain-specific models are not for everything, and that's not the only approach, which I think for me, who went from academia to the industry at the time, and then after a few years realized that's the case, that was the biggest kind of shock and difference. But I do still believe that for a very specific domain, specific knowledge, especially when it comes to the deep roots of this specific task in anesthesia or this specific knowledge in anesthesia and doing it right, since we're dealing with patients' lives, there are cases that you do actually need a very deep understanding, and you want to make sure that is what the model is capable of doing too.
Oh, great answer. I want to back up a little bit. Part of this podcast is about really embarking on, this journey of understanding technology and where it meets anesthesiology, but really getting to the heart of looking at a path to innovating healthcare. And one of my friends, Susanna Fox, used to say that people talk about technology, but what they really mean is they're looking for a solution to a problem. And I think oftentimes when we talk about technology, and we're having a conversation about technology today, we do tend to focus or use a lot of words that can have jargon to them. And I thought it would be good for us to help our audience maybe understand some of the words related to the conversation about technology that they often hear. So Dara, help our audience who may be new to some of these terms, maybe understand the differences between what people mean when they say artificial intelligence versus machine learning versus large language models versus algorithm. We use these words a lot when we talk about these types of new emerging technologies. Could you take a moment to help our listeners understand what these mean?
Right. And I would say it's always okay to, especially if you're not really working in the field, to get them mixed up. But at least for those people who are in the field and who are practicing machine learning and artificial intelligence, it becomes very important to be able to distinguish between them. So for artificial intelligence is basically any sort of algorithm, any sort of computer programming, or any sort of software that can kind of think on its own, looks at any sort of data and gets to a conclusion without really giving the final answer. And that most of the time happens when you throw a lot of data into that software or algorithm. So that's kind of the biggest umbrella of the artificial intelligence. It could be a very kind of a dumb computer that does this one specific thing very well and gets to that conclusion on its own based on the training that it had. But then machine learning is a smaller field, more specialized, and it utilizes a lot of understandings from computer science, statistics, mathematics, and tends to sit and utilizes all the methodologies from all these fields to build and look at the data and understands them and do that in a very formalized approach. And that's why you see a lot of times whether people or companies tend to just keep saying machine learning. And then when you read a book or listen to a podcast, you do hear a lot of artificial intelligence. And the difference between the two is the machine learning, the models and the algorithms, the methodologies all have names and approaches, and it's kind of standardized in a way. Whereas artificial intelligence could also mean a robotic field as well, that might not even have the software, but the hardware itself does imply that there is some sort of intelligence. So yeah, I would probably distinguish between the artificial intelligence. The biggest umbrella includes both the hardware and the software. And then machine learning is often when we are talking just about the software that can learn from the data and hopefully understands it. And then large language models is a more specialized field of the machine learning that just deals with the language data. So the data source for large language models is just the language data that we get, which could be text in different languages, could be the audio that gets translated into text again, video that you get the transcript. So everything gets compressed down into that specific whole language, and then all the models that deal with that, we kind of describe them as the natural language processing, and then large language models is a form or a type of models that empowers that special field. ChatGPT is a great example. It's a large language model that people have been experiencing with, and I guess we're all kind of excited that it's out there. Now we can actually talk about it, and people have experience on what a machine learning algorithm can do, what a large language model can do, and interact with that every day. But a few years back, when we would talk to different people, they would have no idea what we are trying to describe or what we're talking about, right? So it's much easier to define the terms correctly, talk about them, and explain what we're trying to do.
Alex,
Yes.
take us back to the moment when you first realized the potential for emerging technology in healthcare. What was it about that intersection that captivated you and set you on your current path as an AIM Lab fellow, or even as someone pursuing this line of work and research?
Yeah. So I think the heart of my interest in technology and medicine comes mostly from a balance of frustration and hope. And I think a lot of it comes from when I was 12 years old, my mom taught me how to program HTML. And so it was kind of my side gig throughout, college and medical school, was to build websites for people. And occasionally I would do something a little bit more advanced. And one thing that the more and more of this I did, the more I came to realize that the tools that are available for people that build software are very good because they're built by people that do software. And so you start to notice that, I have this need. Someone has fixed that perfectly. Let me download this tool and integrate it into whatever I'm working on. Then when I went into medicine, that doesn't exist in medicine. The timescales are too long. The regulations are significant, though important. And so there are tons of problems that have easy solutions or solutions that, are a few steps away for problems that are real. And for someone who is used to building things, building little applications, it's hard for me to use these tools without noticing how they could be improved. And so I think that was the major motivation, was both frustration from some of the inefficiencies and inadequacies of current implementations of technology in medicine.
Can you give us an example?
Oh, sure.
If you could struggle to find one.
Yeah. What's a good example? I remember when I was on my surgery rotation at the VA Medical Center in San Francisco, every morning, the role of one of the interns, which is someone who recently graduated from medical school, was to have two monitors open, one which was the medical record system, and one which was basically a fancy version of Excel that the department had built for them so that they could view all of the data for their patients at the same time. And the role of the intern was to look at the values on the screen on the monitor on the right and write them into the Excel document on the monitor on the left. And then at the end of this process, they would print out a document that had all of the values that a doctor would want: the meds, the labs, the weights, vitals, that stuff. We want it, and we want it on one piece of paper, because when you're going back and forth between the operating room, you can't carry a laptop with you. So that was the rule. And I looked at this and said, wow, this is something that probably is a weekend project to fix this for, someone who knows what they're doing in software. And it was taking up an entire physician's 2 or 3 hours every day of just mind-numbing work. And this is, if you think that this is a unique instance of this, it is not. And it's not isolated to the VA. It is a universal problem, that there are just horrible inefficiencies built into a lot of our daily
Alex,
practices.
I'm listening to your story, and I'm trying to envision an altruistic motive for the tasks, such as the management or higher ups were envisioning the exercise would strengthen knowledge of the intern of each patient's lab values for the day by having them transcribe the information. But somehow I wonder if that really was the intention or a byproduct of inadequate processes.
Yeah.
What are your thoughts on this?
I think that I think there is value for pre-rounding and going through, looking at the values, writing them down, processing them yourself. but it wasn't necessarily the same. It wasn't the intern that would do it all the time. Sometimes the medical students would be assigned to it. It was just a task that needed to get done, and no one thought it had any actual value because there was a parallel system where you would actually write down all the values. This whole Excel system was mostly to collect like a historical trend data and so the crazy thing is that the more I learned about CPRS, the VA's medical record system, the more I found out that there are actually tools to do things like this built into CPRS, but the infrastructure to connect physicians with the tools they need is non-existent. And so many physicians, based on the kind of the culture of our training, the way that we think about clinical problems, a lot of people would rather just grind through a problem or think that there is no alternative, that this is the way it has to be. And I think that's a product of kind of the way that we teach medical students in a non-creative way, but also the product of like there are significant regulatory hurdles to even getting that data into this, Excel spreadsheet thing. There are legitimate concerns to a lot of these clinical applications. So it's tricky. But either way, it was hard for me not to notice the potential for improvement
Right.
in using physician time effectively.
That's a powerful example. I think one that as clinicians we encounter almost daily in terms of things that can be improved.
How frustrating that is. Like, do you guys get frustrated at that point and you want to do something about it? Or it's just like, since it's so common in different things that you just...
So there were like many days during intern year that I would just stay up hours into the night, just upset at the fact that a lot of my job was difficult for reasons that have technical solutions that have been around for 20 years.
And I think if you look at the statistics, you'll see when you look at outcomes like physician burnout, for instance, and satisfaction with their work, I think a good amount could be due to systemic issues related to how you get things done, the human factors that can play to processes like this. And I won't maybe comment that all of it's technology related. What anesthesiologist hasn't gone to work and opened a drawer and had it just fall out, and been frustrated by that?
Yeah.
I think Alex is smiling because he knows what I mean when I say this.
Yes.
And maybe other anesthesiologists listening to this podcast know what I mean and are wondering, couldn't this drawer be better designed so it doesn't fall out and all of the things spill onto my workbench? So that the little things add up over time.
Yeah,
to be frustrating.
It really starts to wear on you if 30% of the tasks take an extra 25% effort, especially when you know that it's something that could be fixed, with an hour of someone's time, and there's just not a system in place to do it.
And I think that Intelligent Anesthesia, this podcast, is a place where we want to create a safe space to talk about these frustrations, maybe find some smart people, anyone who would like to think about solutions to these issues, and to understand we need diverse skill sets to help solve them. Maybe they don't all have to be within the field of anesthesiology. We're going to talk about in this series other fields like design thinking, like engineering, that can help bring in expertise to help understand human factors, understand some of these issues and how to solve them. So last question for this first episode. Dara, I want you to walk us through your creative process when you are developing new solutions, technological solutions perhaps, in your work. How do you navigate the balance between being innovative, being practical, and ethical considerations in that work?
Yeah.
How do you think and approach those issues?
That's a big question. I would say that I've done it in two different ways in terms of where the start point was. Once I've tried or started at the problem, and the goal was to get to the solution. And the other time was start at a solution at hand and find a problem for that solution, which sounds backward. But yeah, like in my career, I would say, yeah, I've tried those two distinct opposite approaches. Both of them could actually worked at the end, but the one that I started with the problem and got to the solution was far more, I don't know, I enjoyed that process much, much more. And it was a shorter path actually. But the one that the solution was already figured out and there wasn't much left to the discovery phase, it turned out, I thought in the beginning that would, okay, this is great. We just have to find a problem for this solution that we have. And we apply it. And that's, I don't know, shorter, faster. Probably you get to the IPO like way faster and the financial benefit is there, right? But it was actually, I don't know, in my experience, it turned out to be the opposite that was true. So that was surprising to me. I don't know. I'm sure a lot of people here that were like, yeah, that makes a lot of sense. Nowadays, my approach for innovation is to try to listen and really be able to understand the problem. So take a lot of long time in the beginning of understanding the problem, and then everything else starts. So yeah, I think my difference with a lot of folks in my field is that I actually, in the beginning, I'm very slow to get to the starting point nowadays, but it's actually by design and from my experience that I really rather spend that extra time in the beginning and understand the problem and be able to talk to a lot of people and don't say anything, just listen to how they're explaining that same problem over and over, and everything else after that, every process is after that, kind of shorter. And for me, that actually works in a better fashion too. So yeah, I would say that's my key difference than what the typical approach to innovation is, that I take just longer in the beginning and try to understand the primary objective, if you want to frame it as a research question, and the secondary objective very well, that I can simplify it, and in my head is very simplified. Yeah, I'm not sure if I answered your question.
Actually, it seems so basic. It's so important and so profound, and yet not easy always to do, which is to really understand the problem and understand from the end user's perspective what is the issue at hand. Taking a good amount of time to define the objectives and goals before you work on the solution. I think we've all been there, where we just have a cool idea that we want to engineer, and we might even be trying to solve a problem for ourselves.
Yeah.
And then we think we know what the solution is, and then after we design, in fairness to myself, I will say I just created a prototype. And I realized that after engineering the solution, I learned a lot, but that was not what I actually meant I needed. And it was that whole point of engineering that solution was actually needs finding, was me actually understanding what the need was. I'll give you an example. In my real life, we set about creating an app for anesthesia attendings to request breaks. This was to help make it more efficient and more equitable and easy for attendings to get breaks when they work by themselves. And I even worked with another attending on this project, and I engineered a great app where people could push a button to request a break. And quite a lot of engineering went into this app. And we deployed it, and what we realized is that people didn't want to push a button when they needed a break. We only discovered this after we engineered the app. What we did learn is it created a lot of transparency around people who give the breaks. That encouraged people to give breaks, and the break givers use the app to document that they're giving breaks. And so from that perspective, we were managed to eke out success from the project. But it's a story that I think emphasizes, Dara, your point, which is taking the time to really understand what's the problem, and before you make the solution. And I think those type of lessons are what I hope we'll uncover with this podcast, and we can share widely with our colleagues, not only in anesthesiology, but in medicine. So as we draw this episode to a close, I want to thank everyone who joined us today for this episode of Intelligent Anesthesia, as we are journeying through the intersection of anesthesiology, medicine, and innovation, and seeking to uncover the transformative power of technology in patient care. It's conversations like these today that I think will propel us forward and inspire a future where medicine and technology converge to enhance the human experience of healthcare. So remember, this is just the beginning of our exploration. Stay tuned for our next episodes, where we will continue to take a deep dive into the heart of innovation and bring you the latest innovations and breakthroughs in the forefront of anesthesiology. So if today's discussion sparked curiosity, if it ignited passion, or simply offered you a new perspective, I encourage you to share this episode with your colleagues and friends, or anyone interested in the future of healthcare. So until we meet again, keep pushing boundaries, stay inspired, stay curious, and continue to breathe new life into the world of anesthesiology. I'm Dr. Larry Chu. Goodbye and take care.